Hello and welcome back once again to Physicsify. Today we are going with vectors, but this time around we have a new thing to do, and in this class, in this part 11 session, we are going to see the magnitude of resultant vector. We are going with analytical method now, moving from the graphical method towards the new thing. I hope you can understand and like this lesson as much as you did previous ones. So let me quickly revise you things what we know from the parallelogram law. I think everybody remembers that if we have two vectors, say A and B, such that the angle between them is theta, the next thing you can say is, let's draw out that parallelogram. You can say that the resultant that we would be getting somewhat over here like this would be making an angle alpha with A. You know all about this earlier, but now we are taking in the analytical method where there would be more mathematics as compared to the graphical analysis. So now let's quickly revise what we did here. We said that parallelogram law of vector addition told us that a plus b, that is vector a plus vector b, if added vectorially would give this green vector r, and you can also say that the magnitude is the length of its third side. This is probably parallelogram law coming in with the triangle law. The length of the third side, if we consider this triangle, this is that third side. You can take that length as the magnitude of vector r, and you can also consider the direction alpha with respect to a, like I just said. But triangle law and parallelogram law are a thing of past. Generally, once the question comes up to us, we would not be given a graph paper, so doing it graphically is a little challenging. That's where the analytical method comes in, and you are to do with the new method whenever required. Most of the questions would be coming with respect to the analytical method rather than the graphical method. So let's quickly see what exactly does it say. So first thing I would say that if we are to calculate this magnitude of resultant, this is going to be the most important slide, the only thing that we are learning in this session. So please be a little more attentive. We are being said that we have the same two vectors, let us say vector A and vector B, such that the angle between them is theta. Next thing you are said that if you want to get through with the analytical method, let us try to have a rough idea how things would be. So I have translated this B vector from here to here. If you see, there is a small little arrow still present over here. Next thing that I do is I draw the resultant R. Now this can be done graphically, that's absolutely correct. But if there is no graph paper, you can draw this as a rough particular diagram. What's the next thing that we do here? So this is going to be of utmost importance to understand that if you are to prove the formula of the magnitude of resultant, there is one construction that you need to do, and that is draw these perpendicular lines. First of all, you are extending A till here, and next you are dropping a perpendicular from this resultant point towards down. This angle obviously is 90 degree over here. What's the next thing that we do? Next thing we say is that this is again that vector B. This angle is again going to be theta if this full angle was theta. Okay, what's the next thing that we do? We can now define some particular names, right? If you see, I have defined O, X, Y and Z. You can have your own convention, that's not a problem. But the thing to be learned here is that now we are to use Pythagoras theorem on the bigger triangle, that is this one. So let us take this triangle and try to learn more. In triangle OXY, that is this big triangle, I can always say this hypotenuse square, that is OX square, equals OY square, that is base square, plus XY square, that is perpendicular square. So you can see OX square equal to XY square plus OY square. What's the next thing that you can do? The next thing that you need to understand is that this length OZ you know is A. But do you know this length ZY? Right now you don't know it. Do you know this length XY? You don't know it. This obviously you know is r, or magnitude of r, that you know, but getting this xy and zy is important. That is where class 10th trigonometry is going to help you. If I take this small triangle now, that is xyz, I can say for sure this xz is b vector. This angle is theta. That is the angle between x, z, y, right? That is theta. Next thing that you'll do is that you can now say that first of all, if I want to write sine theta and cos theta in this triangle, sine theta is given as perpendicular divided by hypotenuse. So sine theta is perpendicular xy divided by hypotenuse xz. This means I can get this xy length as xz into sine theta. I know this xz is b. So this xy becomes actually b sine theta. Right. Similarly, if I talk about the next case, I will say I can write down cos theta. That would be base upon hypotenuse, that is yz divided by xz. Again, I can say that yz could be said as, this yz could be said as xz into cos theta. So this over here becomes b cos theta. So now if we substitute these two values again, I think I can now easily say that this xy length is b sine theta from here, and this yz length is b cos theta from here. For this we have used trigonometry. So again guys, those of you who are weak in mathematics need to be a little more attentive, because this is something you will need to do in case you are to prove this particular formula. Once we are done till here, now things can be a little easier for us. Now we can say that ox square is going to be r square, xy square would be b sine theta whole square, and oy square is oz plus zy, which is a plus this much, that is a plus this much, that is a plus b cos theta. So this is a plus b cos theta whole square. Once you are done till here, now only calculations remain, right? We have done a little bit of part in mathematics and trigonometry, but now you'll have to do it again a little bit. So once you expand this, you will say this r square comes as it is, b sine theta whole square becomes b square sine square theta. This a plus b cos theta whole square becomes a square plus b cos theta whole square, or b square cos square theta, plus 2a b cos theta, right? Now what I'll ask you to do is, if you see these two terms, I've made this in red specifically so that it becomes easier for you to identify. B square sine square theta and b square cos square theta, if I take both of them, I can club them together and I can say this is a square plus b square times sine square theta plus cos square theta plus 2ab cos theta as it is. And from here I get this final relation, that r square is a square plus b square plus 2ab cos theta. If I want to write down only r itself, it would become under root of a square plus b square plus 2ab cos theta. So this is the proof of how you would get it through an analytical method. Over here we don't need to have any graph. If we just have these vectors a, vector b, and the angle between them theta, you can put down all these values and get the magnitude of the resultant. I hope you really liked this session. So in case you did, you can like and share with your friends. And in case you don't want to miss the next lesson, that would be on direction, I hope you would subscribe right now. See you in the next one. Cheers.